there YouTube and makers, and welcome back to my channel. Thank you for spending your time with me today. On this installment, I'm going to be covering roughing out the journal box axle bearings for the Kozo Hiraoka Pennsylvania A-3 switcher steam locomotive engine in 3/4 inch scale in a 040 layout to run on a 3.5 inch gauge track for the tender rather. Some of you who are paying attention to the book will know that things are a little bit out of order, in that, in fact, I've skipped page 16. This is for a couple of reasons. To really get into and to work on the journal boxes, I quickly discovered that I'm really going to need to either get a mill or some sort of milling attachment. You'll notice that I also said rough out the axle bearings for the journal box. And that is because when I went over it with the journeyman tool and die maker, in the amount of time I thought I was being smart in saying and pointing out that Kozo Hiraoka used a reamer to put an axle bearing in the 3-jaw chuck and that this might not be great practice. In the amount of time that where I just said that, the journeyman machinist, tool and die maker with his 40 plus years experience, mind you, looked at the book, looked at all the dimensions, and said, oh heck no, this is bad. And it wasn't about the reamer, because the reamer was a little bit, yeah, it's not great practice, shouldn't do that, quote unquote. But what was really pointed out to me was that for the bearings, in the procedure shown by Kozo Hiraoka, is that 3 jaws, so 3 little jaws, are going to be holding on areas of just 20 thousandths. There's a proper way to machine these journal bearings, and so it's going to begin first by roughing out and machining all the journal bearings. So if it was the tender only, that'd be 8, or the tender plus 2 pieces of rolling stock or wagons, that's going to be an additional 16. So I'm going to rough all those out first, and then in my next installment I'm going to build a new fixture or jig to finish machining the bearing the correct way, so that you never miss that next step and me finishing up the journal bearings. Be sure to hit that subscribe button as well as a bell notification so you're alerted when that video posts. Likewise, if you're interested in my machine or any of the tools you see me use and suggest or talk about, always be sure to check out the description below. Now, before we get started, there is one little bit of housekeeping. I changed the rate in which I speed up the machining from 3 times to 4 times, because down over here there's a little cog or wheel or gear, and clicking on that brings you to another window in YouTube in which you can adjust the playback rate from twice as fast to 1/4 speed. So in theory, I think, well, the way I'm kind of playing around to see if this works is that for myself or anyone who might be interested in watching this video and machining steps in real time, so matched, by going down to 1/4 rate, you'll be able to see that actual real-time machining. Be sure to stay to the end. I'm going to have another great journeyman tip of the day to share. Alright, enough admin. Come on over here and join me at the bench, and let's make some chips.
I want to begin by facing off. Touch off a couple of times to figure out where I'm at and going about 5 thousandths. Not too crazy. But I can see there's a little shadow left from the saw, so I'm going to go another 3 thousandths and got a nice mirror finish. I'm going to touch it off here again to figure out the outside dimensions. I'm going about 10 thousandths. Off camera, I've already taken the time to dimension everything out to make count the number of revolutions or turns on the hand wheel, make sure my hand wheels are zeroed, and make sure I'm not going to run my cutter into the chuck, because that would be horrible. And I'm just taking these nice little 10,000 cuts. And it's actually kind of enjoyable. It's a very different machining experience than machining some of the steels. It engages the machine very differently. It chips differently. It sounds differently. It smells differently. And the machine moves and vibrates differently. It's a very different experience, and actually quite enjoyable. And I would even say a bit calming and relaxing. Now that I took a few cuts off, I'm going to check where I'm at to make sure that I'm not going to overdo it and to get a more accurate measure so I know how many more turns I got to do, how many more thousandths I got to take off, which roughly got about 56 thousandths left to go. So that's off the diameter, not the radius, so 28 thousandths off the radius. And I'm just going to continue taking 10,000 cuts. It is entirely possible, this machine is entirely able to take bigger cuts, like 20 thousandths. And indeed, when I was kind of messing around and practicing with it, it certainly could. But I really enjoyed machining this phosphor bronze. So I decided just to take the 10 thousandths because it was nice and it felt good. And it was a nice change from after having scrapped some steel axles and having a rough day at work just to machine this phosphor bronze, which is so nice that I move the hand wheel a certain number of thousandths and it takes that exact thousandths off the radius. Now I'm left with 0.410, so I've got roughly 16 thousandths to final dimensions. But again, I'm going to do this oversized, so about 15 thousandths left to take off. And I'm going to split that up and take a smaller cut and part of that 7 thousandths off the radius, and then take a pressure cut and measure again, because I just don't know this material and I'm just not familiar with it yet, so I'm going to take it easy until I get more familiar and learn it. And what surprises me is how much material comes off on a pressure or finish cut, even if I'm only taking a fraction, 5 thousandths. So now I'm down to 0.4012 because I'm a little more concerned about that 10,000 place now. And take off probably an additional 3 thousandths or so off the radius. And take another pressure relief cut here, and still surprising how much comes off. I just don't know if that's the way it chips, but it's very different with steel. And I see now I'm at 0.3954, so about 10 thousandths above the top end of the range. I'm going to begin by getting my cutter out of the way and moving over my table, so I've got plenty of clearance and can reach in there with my center drill. If you've been watching my channel, you've seen this journeyman trick of the day, in which I orientate the cutting fluid rather up and utilize it as a kind of a reservoir to hold my cutting fluid. After center drilling, I'm going to go in with my D-drill bit and do the same exact thing, cutting fluid up, and let it be the reservoir to hold my cutting fluid. And go in there, and once I start feeling it catch or vibrate differently, I'm going to back it out and clear the chips. One thing you're going to notice is that it's going to seem like the drill bit is going in a usually deep distance. And that's because I've decided to lengthen my blank material as long as I can fit in the chuck. So that I have as little waste as possible. Because doing it the way Kozo shows in his book, I found that I had a lot of rems and a lot of waste. Basically, the amount of waste or rems is the equivalent of the amount of journal bearing I was making. So I decided, instead of having a 1-per-1 ratio of waste, I was going to try to make it so that I have one piece of length of waste per to get out 3 bearings. So here I'm going to, after checking it and letting it cool off a bit, and blow it out, and just go about reaming is kind of a typical way. After make sure there's no chips in there, reams quite well, nice and smooth. And when I kind of get everything out of the way and wipe off the table, make sure there's no chips, because I don't want to get any chips, even this phosphor bronze, between my tool holder and the tail, because that'll damage both surfaces. It looks kind of straight, but I can assure you that my tool is at a good angle. For some reason, it just looks really off here in the video. But I'm going to go in and I'm going to chamfer that edge right there. I'm going to touch off and then take off about 3 thousandths roughly. That's chamfered, and get my tool holder off the table and wipe it again to make sure there's no chips to come between my rear cutoff tool. Then I'm going to take my straight edge rule and line it up in front of the table. Bring it in close, double check my dimensions, and then I'm going to count the number of rotations. Get in close again, make sure it's the right distance, get it back there, make sure I clear my chuck, fiddle with the hand wheels, re-zero them. And again, I did all this off video in the first part when I was checking my cutter before I took the first cuts. So once it's all safe and good to go, I'm going to bring it in close. And now I'm going to apply another previous journeyman trick of the day, which I'm going to touch off with a piece of paper. Unusual thing about this note paper that I just discovered is that it is shockingly exactly 4 thousandths thick. So once I've kind of touched off and got that distance to the paper, I'm going to move it in about 3 thousandths to accommodate for compression of the paper. And there's my distance, and you saw there a little jump. And it's because I'm a little insecure because I'm still not too familiar with this. I haven't done too much cutting off, so I'm going to give myself a good 10-20 thousandths or so margin of error just in case, because I have made this oversized. And I'm going to cut it off, but I'm going to make sure I'm going to go consistent speed all the way through and not hesitate, because hesitation is where it breaks.
Today's journeyman tip of the day has to do with cutting fluid. Though it seems kind of mundane, it's kind of important. And it's probably a hotly debated topic that could take hours to really delve into and to really understand, and can get really complicated down to that molecular level. Not going to go to that depth, but going to kind of cover some tips when thinking about and dealing with cutting fluid in a broad sense. Cutting fluid kind of comes down to 3 main categories to consider in a broad sense, really general and broad. So that would be machining type, which some people include, others separate out machining speed. The second factor is material type, so the material being machine. And the third factor is cutting fluid type. Cutting fluid type really simply breaks down to, is it a water soluble? Is it a synthetic? Is it a non-synthetic? Is it a polymer? Is it a combination synthetic, non-synthetic? Is it supposed to be doing a lot of cooling? Is it with a flood system? Is it, so like this Sherline doesn't have a flood system. There are other people who built a system, a coolant feed system, the flood your cutting and then collect in a basin and everything else. Mine doesn't, so it's going to be dabbled on with a brush, as you've seen me do in this video and all my others. Now when it comes to the first factor, knowing the machining speed or operation type, that further breaks down into 4 additional categories, and those could be cooling, lubrication, chip removal, so flushing away the chip, corrosion control, but then also viscosity. And viscosity has to do with where it bleeds into some of the other categories. Is it a really hard material to machine? Is it a really soft material that's malleable? Is it going to be a high rates of feed, like for titanium nitride carbide, that's going to be taking out big chunks, etc. And the last category, which I think is very important as well and really applies here, is material being machined. In this video, you saw me machining phosphor bronze, and my primary cutting fluid, with which you saw me using throughout this video, has been aluminum cutting fluid, and it was selected based on the recommendation to me by the journeyman machinist, and that while the phosphor bronze didn't necessarily need or absolutely have to have a cutting fluid, it was very useful and important in which it would stop a condition called chip bulb, in which chips sticking to my carbide cutters. And this was especially important in my instance in that having that extra bit of fluid helped the chips to not weld on my cutters and allow them to slip off so that they wouldn't impact and scratch and affect the surface finish of my phosphor bronze bearings. Thank you so much for joining me today and spending your time with me. Hopefully you enjoyed that, and if you did, be sure to hit that subscribe button so you never miss another episode, as well as the bell notification. Additionally, feel free to comment and share. I love hearing back from everyone and really do enjoy the conversation and the going back and forth. Now, if you're interested in any of the tools you see me use, I try to post links to them below, so be sure to check them out and be sure to see if they will fulfill and fit your needs. Next time, I'll be discussing working on putting together that holding fixture device to finish up these axle bearings. Thank you again for spending your time with me. Have fun out there, stay safe, and keep making chips.